What's up, math scholars? We're doing 10.6 day 1. We only have 3 lessons left this whole year, so that's something to get excited about. Yeah! So that means only 3 more lessons and 3 more homeworks, okay? Yes, this is one of the 3. Okay, so I just passed out a little slip of paper with all of the sum formulas. You use this if you're doing sums. All of the difference formulas, you use these if you're using the difference. And they're really kind of long, intense formulas. They almost remind me of the law of cosines back from chapter 9. But they're actually not all that hard to use. It does say, in general, sine of a plus b would not equal sine a plus sine b. If you're doing sine a plus b, you better use that long sum formula. Okay, so have that paper handy as we're doing the lesson today and as you're doing your homework tomorrow and the next day. Okay, so let's start off with sine 285. Can you guys look for 285 on your unit circle for me? It's not there, is it? So what we're going to do, and there's more than one way of doing this, we're going to come up with 2 numbers that are on the unit circle that would either add to 285 or subtract to give you 285. And there's more than one way of doing it. So can somebody give me 2 numbers that are on the unit circle that would either add or subtract to 285? 240 and 45. They would add to 285. Perfect. So we'll just call that the Lexi method. Now I did this problem last night to prepare for my lesson, and I selected 225 and 60. And guess what? Me and Lexi would end up getting the same answer, and that's what makes these ones cool. You could even have picked 2 numbers that subtracted to 285 and still got the same answer. All right? So here's how it's going to work. We are going to use the sum formula for sine a plus b. We're going to let a be 240, and we're going to let b be 45. So I'm going to take my little slip of paper and just write out my sum formula for sine. Make sure you're using the one for sine and not cosine. So it's sine a times cosine b plus cosine a times sine of b. Just wrote that down straight from the paper as the very first one on the paper. Let me know if I get going too fast. I get excited. These were fun, I think. Okay, we're ready to plug some numbers in. Everywhere I see an A, I'm going to put in a 240. Everywhere I see a B, putting in a 45. So sine 240, cosine 45. Cosine 240, sine 45. Do you see what just happened? All the A's are now 240. All the B's are now 45. Unit circle time! Let's look at our unit circle and actually start looking for some of these exact values. What is the sine down at 240? The y value down at 240? Good. So I'm going to substitute that in for sine 240. What is the cosine up at 45? Yeah. So if you don't have your unit circle up yet, now would be a great time to get it out. Cosine at 240 and sine at 45. So it's kind of mind-blowing that had I used different numbers than Lexi had used, which I did, I used 225 and 60, I could have ended up with the same answer at the very end. All right, so we're going to simplify this final answer, but then we'll be done. I normally treat my negative sign as though it's with the numerator, so I would treat this as a negative radical 3 times a radical 2. That would be a negative radical 6. The bottom would be 2 times 2, which is 4. Over here, it'd be a negative 1 with the radical 2, so that's negative radical 2. Over 2 times 2, which is 4. Okay, are these like terms? Or I'm sorry, do they have common denominators? Because we're adding fractions. They do. So I'll put them all in the same fraction together. It's negative radical 6 plus negative radical 2 over 4. And those 2 in the numerator cannot combine. They're not like terms. They have different people in the radical symbol. All right, here's our next problem, cosine 75. If you would look on your unit circle for 75, you'd be like, uh-oh. Not finding it. So we're going to find 2 numbers that would either add to 75 or subtract to give me 75. Both of those numbers being numbers on the unit circle, of course. 45 and 30. That's probably the most obvious choice. Now, believe it or not, when I did this last night, I don't know what I was thinking. My brain must have not been turned on. I used 120 minus 45. So that was unique. But we'll end up getting the same answer as one another. So 45 and 30 is the most obvious choice to be able to get a 75. I definitely agree with that. Now, this is a cosine problem, though. We're going to let A be 45 and let B be 30, but we're going to use the sum of the cosine. Cosine sum formula. Let's just say let. Okay, so cosine sum formula, I'm just going to write it up here. Cosine of A plus B equals cosine A times cosine B minus sine of A times sine of B. How are we doing paying attention? We get it so far? Okay. So here's where we get to do plugging and chugging and figuring things out. Everywhere you see an A, you stick a 45 in. Everywhere you see a B, you stick a 30 in. Does that make sense? Why? Because the 45 and 30 are the two numbers we select to be able to get that 75. It's not the only way to do it. It's just, it will get you the correct answer then. All right, so it's cosine 45, cosine 30, minus sine 45, sine 30. And when I check this, make sure I didn't mess anything up. Looking good so far. Oh, I love this because 30 and 45 are both in quadrant 1. So these will all be positive answers. That's nice. Unit circle time. All right, cosine 45, what is it? Okay. Cosine 30, what is it? I have a big minus sign. Sine 45 and sine 30. Okay, simplify time. My numerator for the first fraction will be radical 6. My denominator will be 4. My numerator for the second fraction will be a radical 2. My denominator will be a 4. So it looks like my final answer. Oops. Radical 6 minus radical 2 over 4. Now at this point, some of the scholars are looking at the first problem going, oh my gosh, that answer is super, super, duper, duper similar. All these answers will look super, duper, duper similar because they're all coming from 1/2 radical 2's over 2's and radical 3 over 2's. Okay, so they're all going to look similar. They might have minuses and plus signs in different places. All right, this is for the scholars among scholars. It'll separate the men from the boys and the women from the girls and the scholars from the non-scholars. But we are going to use a difference formula because we're trying to find cosine A minus B. We're given some pieces of information, which is really nice. Let me circle the given information. They give us that cosine A is -4/5, with angle A living between pi and 3 pi over 2. Now, people watching the video can't see this, but I have a unit circle drawn on my whiteboard. What quadrant would angle A live in if it was between pi and 3 pi over 2? Quadrant 3 down here. Makes sense? And if angle A lives in quadrant 3, he's a negative guy, meaning his cosine will be negative, which they gave me, but his sine will also be negative. So before I even start solving for sine, I know this answer is going to be a negative, so maybe make note of that. Sine of A will be negative because A lives in quadrant 3. All right, let's talk about what we know about B. We know that the sine of B is 5/13. We know that angle B lives between 0 and pi over 2. So what quadrant is angle B in? Which is awesome. I love when people live in quadrant 1 because they're positive people. So before I even start, I know that my sine will be positive, and I know that my cosine will also be positive. So it's going to be our job to find sine A. It's going to be our job to find cosine B. And then we'll have all 4 things we need to do the final formula. So it's not too hard mathematically, it just takes a little while. To start off, finding sine A, we're going to use the Pythagorean identity. Do you remember the real famous one? Sine squared A plus cosine squared A equals 1. We did the same exact problem with the same exact method last week. Alright, so we're trying to find sine. We obviously don't know it yet, but we do know cosine. So I will plug cosine in. Negative 4/5. Negative 4 squared is a 16. 5 squared is a 25. What step would come next? Subtract. I am not going to write the subtract step down to save space, but that's what we're doing right now. So here is what we're going to type in. 1 minus 16 over 25. Math, enter, enter, because making it a fraction will be awesome. So sine squared a is 9 over 25. I got that by subtracting that over and fractioning. Last step, square root. When you square root something, you get two answers, a positive and negative. But we've already determined this answer must be negative. So the square root of 9 is 3. The square root of 5 over 25 is 5. So it's negative 3/5. Sine a is negative 3/5. I'm going to write it really neat. So do you follow how that happened? Okay, so we have 3 of the 4 pieces of the puzzle. Awesome. And we have one more thing to do. Solve for cosine b. Same exact strategy. We need a second to catch up. Okay, so we're solving for cosine b. We're going to start the same way with our Pythagorean identity. Sine squared b, we're doing b this time, plus cosine squared b equals 1. And I know sine of b is 5/13. We're squaring that. Alright, we're going to square the 5 over 13. 5 squared is 25. 13 squared is 169. At this point, we can subtract over the 25 over 169. Maybe I'll just write it up here, because I know people hate when I don't write it. I'm subtracting over the 25 over 169. That'll give me cosine squared b equals, let me type it, 1 minus 25 over 169. Math, enter, enter. 144 over 169. Then we're ready for a square root. Square root this, square root this. Now we already said b sine or cosine b has to be a positive because b is in quadrant 1, so I don't need to write down anything about any negative answers. It's 12 over 13. And that's the fourth and final piece of the puzzle that I need. Oh, you tired yet? Do you still have space? Because we have one last final step, compiling it all together. We get to use a sum and difference formula to find what they actually want us to find. They want us to find cosine of a minus b. Okay, so I'll grab my little simple paper I taped in today and write down the difference of the cosine formula. Cosine a, cosine b, plus sine a, sine b. And we're just going to substitute in those 4 fractions that we had solved for earlier, and then just simplify our answer. Here goes nothing. Cosine A, they gave us that at the beginning. Negative 4/5. Whoa. That's the second time my board did that today. Okay. Cosine B, we solved that ourselves. 12 over 13. Sine A, we solved that ourselves. Negative 3/5. And sine B, they gave us that at the beginning. 5 over 13. So we'll just make that look a little bit nicer and we'll be done. Negative 4 times 12 is negative 48. What's 5 times 13? 65? Yeah. And then negative 3 and 5 is negative 15. And 5 and 13, 65. Would you look at that? We have our common denominators. That's awesome. So negative 48 plus negative 15 is negative 63. And then our denominator is a 65. So I'm proud of you guys for sticking with me. That was really long. But look how scholarly that looks when you're that. And you're like, man, I'm pretty much a math scholar. The homework is a half sheet of paper. If you're at home because you're sick today, it is located at the end of the note, so just find that in Polaris. Everybody else, I'll be passing it out, and have a happy Thursday. Thanks for watching.